Hi, I'm Debbie Cook, Vice Chair of Cohasset's Alternative Energy Committee. I'd like to welcome you to our monthly educational forum where we bring local experts and businesses to discuss ideas that can save you energy and money. Tonight's forum is on energy-saving hot water heating solutions. So we are really happy to have John Moore from New England Solar Hot Water joining us tonight. Heating your hot water consumes the second highest energy in your home. So choosing the right hot water heater can make a big difference on your pocketbook. John Moore is a registered architect working full-time for New England Solar Hot Water, providing help with sales, marketing, and design of both solar, thermal, and heat pump water heater systems. Over the past 10 years, the company has successfully designed and installed over 2,000 solar systems in the New England area, including systems for single-family homes, as well as for commercial sites, including apartment buildings, dormitories, and industrial facilities. So welcome, John. Thank you for coming. And I am very interested, as I am a potential consumer, in learning all the different options, because I know there's definitely a lot to learn about what's available out there. So thank
Okay,
you.
well, I can start with a presentation. I'm just curious, your existing water heater is what? Is it natural gas?
It is electric.
It's electric. Okay,
Yeah,
good, good.
yeah. So it's
All right.
electric.
I'm going to try and do a screen share here. Hold on a second. Let me make sure this works. Okay. Can you see that?
Yep.
Logo? Okay. So this presentation, I know that's not your logo, you folks from Cohasset, but some of you may have seen this presentation that I did for Sustainable South Shore, Judith Van Ham's group that is quite a large group. If you don't know about it, it's really worth checking them out. They've got quite a few people all over southeastern Massachusetts that are tuning in. And so this is a presentation that was presented for them, and I think it's also appropriate for you all. So glad to hear you have an electric water here, because that's where everything seems to be going these days. Why electric water heating? So it's a significant major trend towards electrification. In many states, Massachusetts, like many other states, they have a decarbonization roadmap, which includes push towards electrification. And there are national and local efforts to electrify buildings. So owners and engineers are considering all electric options for domestic hot water and keeping fossil fuel burning off-site or not at all. And as Debbie was saying, hot water is a large portion of a single-family home's energy load. So this slide is from Abode Energy. It shows the energy in average homes on the left versus a new energy efficient home. So you can see as homes are getting tighter and building envelopes getting tighter and space heating systems are getting more efficient, domestic hot water requires a larger percentage of the overall energy use. It actually becomes the largest energy use in these net zero homes. So efficient hot water systems are becoming more and more important. Hot water here in these pie charts is in red. You can see the average home around 20% of your total energy use. In a net zero home, it's almost 50% just for the hot water. Now, here's a chart. It's showing 4 different options for electric water heating here in Massachusetts, family of 4. Simple on the left, starting from the left, simple, inexpensive electric resistance, probably what you have now, Debbie.
Yep, that would be what I have.
Okay. Solar hot water with electric backup to the solar thermal collectors. This is a common unitary, we call it unitary heat pump water heater. It's all in one unit tank with all the heat pump components on top. And the last is a split heat pump water heater. I'll show this slide again later, but you can see highlights in green and lowlights in red, showing electric resistance right here as the least efficient, but also the least expensive. Solar hot water, the most expensive, as also the most efficient. Heat pump water heaters are an affordable and efficient option. And the new split heat pump water heaters are an option for tight homes when use of interior air is not as feasible. You can see the red in the unitary, mainly about most of this heat pump action happening inside the home. Split systems, a lot of it happens separately from the tank. And I'll explain that. And I'll go back to this slide at the end to go over more if you like. But you can see system costs. These are the tax credits and the incentives that are available in Massachusetts. Obviously none for electric resistance, but solar hot water, heat pump water heaters, split heat pump water heaters, they all have generous incentives in Massachusetts. So here you can see a 20-year cost of each option: electric resistance, heat pump water heater, solar thermal. So the blue shows the install cost after the incentives, and the red represents 20 years of operating that cost. So the most common and least expensive to install in blue is electric resistance and integrated heat pumps. Solar hot water systems typically include a stainless steel tank built to last 20 years or more, and their electric usage is lower, so they offer the lowest 20-year cost, total cost. So a lot of people ask about PV and how PV interacts with hot water. If you have an electric water heater, your PV panels can provide the electricity for that electric water heater. The question is, how many panels are necessary for each of the types of water heaters? So this diagram shows the roof area required for 10 to 12 PV panels to power a standard electric resistance tank. So it would take 10 or 12 panels to power a tank like yours, Debbie. For heat pump water heater, or if a solar hot water system with electric backup were installed, fewer PV panels would be required to cover the load. Only 5 or 6 for a heat pump water heater, and only 2 or 3 for a solar hot water system with electric backup. I'm going to go over solar hot water first, that technology. I just wanted to make this slide just to show that they've been installed in the US for over 50 years, more like 75 years. It's a very standard, easy to understand technology. There's thousands of them in Massachusetts alone, single family homes, large commercial buildings, very time tested. And they work very easily. We're all familiar with the car dashboard absorbing the sun's radiation, heating up even in winter. This exemplifies the simple principles in a solar thermal collector, with pipes containing solar fluid placed in an insulated frame behind a glass panel, similar to a car windshield. And these pipes get super hot. They contain fluid. When the sun is hitting there right on, that fluid can get up to 250, almost 300 degrees in there. Here's a diagram of a typical single tank residential system. So 2 to 3 collectors on the roof, piped to and out through this closed loop here, piped to an 80-gallon solar storage tank. The closed loop piping contains a water mix with glycol, so there's no freezing, and is pumped through the collectors and the heat exchanger in the tank. When the tank is fully hot, or when sun is not available, the system turns off and the fluid drains into what we call a drain back tank. So it's non-pressurized, it's drained back, so it eliminates any possibility of freezing or overheating. For periods of less sun, mostly in the wintertime when the sun's low and we have short days, the system can rely on an integral electric resistance backup shown here. These systems are simple, with the pump being this little pump here is the only moving part. There's no compressors, there are no fans, there are no filters, it's not pressurized, and there's no refrigerant, which is also a global warming fluid. There's no refrigerant in these systems. The glycol is actually food grade polypropylene glycol. So totally non-toxic. Here you see examples of systems installed for larger 2 to 4 family properties with 4 to 5 large collectors, usually with a larger tank. If there's no common hot water system, the systems can be designed to preheat 2 to 3 separate water tanks in a 2 or 3 family. Here you can see a system with the collectors on the garage. The lines, they had PV on their roof, so they put the solar thermal on the garage here. The line set piping was in a trench to the main house and preheated 2 tanks for 2 different units in that building. Any facility that uses hot water is a potential candidate. Here you see small systems serving a farm in Bridgewater, dorm meditation center, larger system serving a brewery. You can see the storage tank here, the solar storage tank here, and these are the beer containers. Large systems work on the same principle as smaller systems, just the components are sized up. More collectors, larger storage tanks. The array on the upper left is part of a system for UMass Amherst serving their central steam plant. Okay, so let's look at unitary hybrid heat pump water heaters, which move heat from the surrounding air into the water tank. These units are common, especially in southern climates where cooling interior air is actually a benefit. So when these units are cooling, taking heat out of the surrounding air, they're cooling the space they're in. And that's fine in air conditioning zones, not so much in heating zones. Here's a schematic showing the heat pump components placed. They're all placed snugly in this. This is a diagram of this section here, snugly in a compartment on top of a storage tank. The heat pump water heaters are 2 to 3 times more efficient than a conventional electric resistance water heater. And it uses a fan to blow air over these evaporator coils to move heat into the water tank via condenser coils around the tank. So these coils and the evaporators full of refrigerant that takes heat, that moves heat, kind of just like a refrigerator, moves heat, in this case, moving it to the tank rather than out of the refrigerator, like a refrigerator works. The tank includes, right here, you can see a couple of them, backup electric resistance heating that's utilized if necessary. If you use quite a bit of hot water and you need it faster, or if the air conditions are too cold, then these electric resistance heaters can come on. These units work well in a space with excess heat, or like if it's next to a fossil fuel boiler that has a lot of excess heat, then they will, because they will cool and dehumidify the surrounding air year round, winter and summer. Skip there. This is kind of a complicated slide. It's from a very intelligent engineer professor studying cold climate performance in Canada, this Stephen Harrison. And it shows these heat pump water heaters and the climate, what's best for each climate. So besides the unitary units I've described, there are other versions of heat pump water heaters. On the left, you see the ideal setup of a unitary unit in an exterior space in a warm climate. They don't have freezing, so they can put the unit outside, doesn't disturb the inside at all, and they don't worry about freezing because they're in a warm climate. Not good for a cold climate, obviously, because of freezing. Next is an indoor installation, which can have problems in a cold climate like New England due to the cooling of interior air. Here in Japan, they often install these split heat pump water heaters by separating the tank from the heat pump unit, which is placed outside. The issues with interior fan noise and room cooling are avoided, but these units pump potable water outside, and this can be a problem with our super cold temperatures in New England. The last version is solar-assisted split heat pump water heater. It's kind of a new variation, although they're very popular and common in Europe. In this case, only the evaporator function remember in this diagram here, this evaporator function right here, that is the only part that is placed outside the house. The panel takes advantage of exterior ambient air and solar gain if available. There's no fan and there's no potable water pumped outdoors. Only the refrigerant loop is pumped.
Hmm.
So here in New England, unitary heat pump water heaters, they can't be placed just anywhere in a house. They require at least 800 cubic feet of airspace around the water heater, and they'll cool and dehumidify the surrounding air. So that's fine in the summertime, but we have long winters, and in tight homes, they make the space heating systems work harder, thus reducing the overall efficiency of these units. They work well in space with excess heat, like a conventional boiler room, but they don't operate efficiently in a cold space or where fan noise is a problem. The heat pump mounted on top, they're tallish and they need space for accessing the fan's filter on top. So they need a fairly high mechanical room. The piping requirements are similar to a common water heater, except that a condensate line and drain is required. Electric service is pretty much the same as a electric resistance water heater, 30 amps. So for some homes, a split heat pump water heater that I talked about in that diagram with the evaporator panel outside makes sense. In this system, you can see the evaporator panels mounted outside, and the remaining heat pump components are actually in a separate unit here near the tank. You can see it here in this photo and here in the diagram. Only low pressure cold refrigerant is pumped outside through these lines here and heated by ambient air and solar radiation if available. The advantage of these split systems is their simplicity and their relative low cost. There's no fan or associated noise, no potable water, no condensate drain, no stealing heat from the inside room. They're relatively easy to install. The panel does not necessarily have to have perfect solar orientation because it's mainly working off of ambient air. So it's most often mounted on an exterior wall near the tank, not on a roof. So split systems like this can thus be a good option for tight homes or those with separate mechanical rooms or those without separate mechanical rooms or no basements. Compared to unitary heat pump water heaters, efficiency is a bit lower. You'll see efficient here, COP of around 2.6. Most of the unitary units are rated more like 3 to 3.5. But because they have no effect on space heating, the overall efficiency is actually very similar. And thanks to tax credits and rebates, they're only a bit more expensive than common unitary heat pump water heaters. Here's an example case study of a single family house. We've been installing these split systems for 4 years or so. We have maybe 300 installed now, no major issues. This is an example for a family in Newbury. Their PV system was actually overproducing. So they had extra electricity they were just sending back to the grid and not getting full credit for. So replacing their fossil fuel-based water heater with an efficient electric heater made sense. But the mechanical area is also used as a working artist studio. So a split heat pump offered the advantage of quiet operation with no impact on the interior air temperature. Another example here, project we just finished, 21 single-story little house apartments. So these split systems are a really good alternative for affordable housing projects like this one, where the homes are very small and tight and electrification is the goal. So you can see here, they used heat pumps they converted these from gas and they put heat pump space heating in, and then they use these split systems with the tank inside the house. You can see the heat pump unit here, tank here, and the evaporator panel outside. A unitary unit would not work in these homes because they would make them cold and loud and affect the air volume inside the house. Another example here, we're doing a project in Dennis. This is going to be, these are attached townhouses where we're going to do, I think 12 systems. And the same idea, you can see here, a couple of little evaporator panels here that will serve this entire building. There's going to be larger tanks inside, again, with electric backup, heat pump water heater. Couldn't put in unitary units because they would affect the inside of the house. These are very tight PV, very tight, highly insulated homes, almost net zero. So they put in electric resistance water heaters. We're going to replace them with these heat pump water heaters and cut their electric usage in half by 60% or more. Big savings here. You can see the number here for these
Wow.
buildings. So here's the chart again, showing the different options. You can see electric resistance, 2,500. This is all of these are robust systems. So I picked this is for a family of 4. I picked a heater that's made by Rheem. It's a marathon tank, which actually has a lifetime warranty. It's a wonderful tank. If you're going to electric resistance, this is the way to go. About $2,500 installed, but efficiency 0.95. Solar hot water, you start at around 9,000. This is family of 4, a couple collectors, that 80-gallon tank. You got a tax credit, you have what's called an AEC rebate, and you end up at around 4,600. So it basically cut in half the price thanks to incentives. So still much higher than all the other alternatives, but the COP, UEF, we call this is the coefficient of performance, how much energy you get out for each unit of energy you put in. Electric resistance, you actually get less out than you put in. Solar hot water, you get 5 times what you put in out. Heat pump water heater, there are incentives here too. There's federal tax credit and a rebate from Mass Save. You're down in the 2,600 range, 2,700 range. UEF, COP is also called UEF. 3.45 is an average for these. So they're pretty efficient. The issue is the fans and using interior air on those. And then the last is the split heat pump water heater, more expensive at the top, but they have a higher rebate because Mass Save recognizes that they are saving heat energy from space heating. So they have double the rebate. Tax credit's the same at 30%. And so they're about $1,000 more than the unitary. The UEF is lower, but when you take into consideration the space heating, they're about the same in terms of efficiency. So that is my presentation. Happy to
Thank you.
go back to slides or answer questions.
Yeah. If you could just go back to the last one.
Sure.
Yes, it is definitely a lot to take in.
I know, sorry.
Oh, no, I think that's great. Does tankless water heaters fit into this?
A tankless water heater is in terms of efficiency is the same as electric resistance. It is electric resistance. The only difference is that if you have tank losses, if you have losses from the water, if it's not a well-insulated tank, then a tanked system could use a little more energy because of tank losses. But most electric tanks now are very well insulated and the tank losses are minimal. So basically a tankless electric water heater uses the same amount of energy as a electric resistance. The problem with tankless electric water heaters is because they require a huge spike of energy when you turn the water on, because they have to it's the same as your boiling water, your coffee maker, heating up that water instantly. That's a huge spike of energy. And when you're trying to provide a shower or a bath or a faucet, your electric panel has to be sized for that. And for a home like a family of 4, you'd have to have basically double your electric service. Most families now have 100 amp, some have 200 amp services. If you were trying to heat water with a tankless system, in a family that size, you'd have to have 400 amp service, double your electric service. So they don't really work too well for typical homes. They can work well for like a point load. If you have one faucet or one shower that you want to be able to heat electricity at the source, they can work well. But efficiency wise and expense of upgrading your service kind of makes them less popular.
So you said that there was one house that had solar, it had excess solar. And so
Right,
you could apply it to the solar hot water. So
right.
I I have solar in my house.
Yes.
So there's a way that I could pull some of that power in and put it into the hot water?
Yeah,
It
well,
doesn't need
you
its
would do that.
own.
Yeah, the electric water heater would be just like any appliance, your dryer or your electric range or whatever. So when you produce power, here in Massachusetts, it's mostly net system, so that when you produce power, it actually goes to the grid, and then
Right.
when you use it, it comes back, and you get credit for the power that you sent to the grid. And now at the end of the year, after a whole, now some months you probably have extra, and you have credit on your bill, and some months you probably have to still pay because you're not producing as much as you use. Is that true with
That
your?
is true. And
Yeah,
we do have a couple of big, big electricity
yeah,
users. We have a Tesla,
right,
and so a
right,
swimming pool. So between
right,
those,
right.
um, we,
So for most people, that's the case, is that their PV system at the end of the year, they don't end up with a credit. They might have some months in the summer when they get credits, but they usually use them up, especially in the winter when there's not as much sun. So if you now in your case, your electric water heater is using twice what it should be if you did a heat pump, or solar hot water would be a quarter of what you use now. So that would add credits to your bill,
well, that's
basically.
good to hear.
Yeah,
And
that
yeah,
would add
any way
credits to
that
your
we could
bill.
get some of these energy hogs out, that would be
Well,
fantastic.
electric car, I mean, it's great you're doing all electric.
Well,
The car is
definitely trying to go all electric and
right, right,
so
right.
really yeah, so we're almost there. We're almost there because I totally
Yeah,
believe in it. So I just wanted are there any, I think I mentioned to you before we started this that we've had two, accidents with our water heaters, our electric water heater, where they just, gave and filled my
yes,
basement with water. Um,
yes.
are any of these systems, do they have any warning signs or anything that, can trigger you and
In terms
prevent
of
those
flooding,
accidents? Yeah.
yeah, yeah. Well, electric resistance water heaters, typically, this is not an example because this is a marathon lifetime tank. This is actually made of a plastic-like material, so it doesn't corrode like the typical steel tanks that you probably had in the past, and they're very common. Those tanks corrode usually 6 years, 5 to 8 years, depending on water quality, the steel ones. And the only way you can get a warning on that is if you have a pan and you have an actual flood, when the leak happens, you actually have a flood alarm in that pan. Um,
Hmm.
Now, the thing that a lot of people don't realize is those steel tanks, they have in them what's called an anode rod. And that is, I wonder if that's in this picture. Wait, no, they don't show it here. Um, the anode rod in the tank attracts the corrosion to keep the tank from corroding. You probably never changed your anode. The anode rod would can disappear within 5 years, and it's best to change them every 3 or 4 years and change them with a new anode rod, and that keeps your tank from corroding, and then they can last 10, 15 years without a
Wow.
problem.
Now,
No
no
one,
one tells you that, do
no,
they?
I know.
I've
It's in the
never
owner's
heard that
manual in
before.
fine print, you know, they want to keep selling tanks, so they don't really
Yeah,
publicize
and
it,
flooding
but
basements, I guess, because
yeah,
it's
I know. That's really sad. I'm sorry you had to go through that. So changing anode rods is an option. Now on these, solar hot water generally have these obviously lifetime warranty, so they just won't leak. Um, these are stainless steel tanks also with lifetime warranty, which won't leak. Heat pump water heaters are typical steel tanks. I think you can get stainless steel versions for a lot of money. But typically they're steel tanks with anode rod. So if you change that anode rod, they'll last and they'll be fine.
Mm,
Uh, it usually starts with a small leak. If you're really worried about it, same thing, pan and flood alarm device.
good
Uh,
to know. Yeah,
these
because I
are
think
steel,
ours just came out of the side. I mean, I don't think
it's
there'd be
burst.
a pan
Yeah.
there. It just
I
kind of,
mean,
yeah, it kind of
yeah.
burst.
I mean, the
So,
least expensive ones, that'll happen. Uh, these are interesting because they have what's called a powered anode rod, so it never has to be changed. It's plugged in. It uses tiny, like minuscule amounts of power, and is always working. So these tanks, even though they're steel, they're not stainless steel. They have a powered anode, so they last 15 years plus without a problem, without corrosion.
so what makes them actually come to the end of their life then?
Well, what can happen is I mean, after 15, 20 years, even the anode rod might give out. But the main working parts of both heat pump water heaters is the heat pump unit. Here it's separate in a little box here, and here it's on top of the tank. There's a lot of moving parts in there, but it's very similar to a refrigerator. What's going on here is the same that's going on in a refrigerator. There's a compressor, there's a fan, there's evaporator coils and refrigerant being pumped around. Um, those are the parts that can go. They're very common, and you know how long good refrigerators can last without being touched. That's true here too. They can go 20 years without being touched. And the components for these unitary are simple, but they're all built in. So if they go, the whole tank has to be replaced.
Mm.
Here, you can replace just this unit, keep your tank, keep the panel, and just replace this unit for a lot less money.
So you're basically saying for a New England environment, the split, um, you know, hot water is seems like that is more the recommendation.
Yeah, depending on the home. I mean, if you have a home with a big old oil boiler or gas boiler blowing hot air around in your basement, then one of these will work just fine right next to it, just fine. It'll be very happy eating up that excess heat off that boiler. But if you have a tight home where either this is near a habited space where you don't want to listen to a fan or feel it get cold, then this would be a better option.
Okay.
Mm.
Wow. Well, I can't thank you enough. I think you've given us a lot to think about. And I think on the Alternative Energy Committee, we are trying to let people know about the resources that are available. New England Solar Hot Water. And basically the move towards all electric, I think is really key. I think that's something that we're really trying to stress. And in Cohasset, about 80% of our greenhouse gases come from residences.
Mm,
So that is an area that we really need to start really addressing. So
yes,
I can't thank you enough, John. And
thank you.
I this was very informative. So anyway, thank you
All
again.
right, talk to you again.
Um, I don't mean to interrupt, but it
Sure.
looks like Steve Wenner has his hand up if he is allowed to speak, although he is on the attendees list.
Sure, Steve, sure.
Uh, hi,
Hi.
John. I want to make sure that I understood the split heat pump idea has the advantage that it's like having the heat pump outside, but only the evaporator outside. So instead of having to move water in and out of the house, you just move the coolant in and out of the house. Is that correct?
Correct. Yeah.
Oh,
This
okay.
diagram shows it. I don't know if you can see that. So that's refrigerant going in and out. So that's the reason that they're more expensive, is because the installation of those refrigerant lines. It's not all
Okay.
packed together like the unitary system. So that's what adds cost. Mhm.
So how hot can a heat pump water heater heat the water?
Well, we usually set them hot because up to, you have a set point on these, but it takes time. Like any heat pump, it takes time. The recovery is slow compared to electric resistance. Um, but they'll get up to 140. We usually set them at 140, 145, because that way you're storing more energy and not have to wait for the heat pump. Because we always add mixing valve. That's not shown here, but we always add a mixing valve when the hot water out. So it mixes with cold, so that if this is 140 and you only want 120 or less up in the fixtures, you won't use as much of this because you mix it with cold before it goes up to the fixtures.
Okay.
Right?
I have one additional question here. It's a little bit off the topic, I guess, but I'm curious about the possibility of circulating hot water to heat the house, just not to heat your domestic water, but also to heat the house.
Yes.
Is that a possibility?
Well, there are some systems coming out now, larger systems for space heating. Same idea. You use a heat pump. Usually they look more like space heating with a unit like this outside, because you want larger capacity. But the water that's produced, remember, there's no tank. Some of them do have tanks, but when you want space heating, you want it hot and you want it instantaneous, pretty much. If you are thinking of a baseboard system with, like common boilers use now, that is very high temperature water going around, 160 to 180 plus. Heat pumps can't provide that. It's very high temperature because its exposure is just these small pipes around the baseboard. If you have, on the other hand, radiant heating, where the whole floor is piped, then heat pumps can keep up, because that temperature is more like 100 to 110, something like that. And
Okay.
so then they can keep up. They aren't common. They're kind of just starting to be developed by manufacturers, and of course they're expensive because you have to have a whole radiant floor for distribution. There are others that have use air. So so you have a fan coil unit where the hot water is pumped at 100, 110 degrees and you blow air over that. But that's not much different than a mini split that's all air. So it doesn't really,
Yeah.
for homes, that isn't a very good option compared to common mini splits.
Yeah.
Yeah.
Well, I asked because we have circulating hot water baseboard heating now,
Yeah.
and my wife doesn't like blowing air from a
Right.
normal mini split to heat pump.
Yeah, you're not
She
going to
prefers.
find a heat pump that can provide that hot water
Okay.
baseboard. If you went to radiant, you could do it, but
Yeah.
but
Okay.
baseboard.
Thanks.
Yeah.
John, could I just ask one question? The outdoor evaporator panel,
Yeah.
I mean, what kind of requirements does that need? Does that have to be, the same alignment as like a solar panel, or can it
No,
be
not
vertical, or?
yes. It's usually vertical, actually. I should have some other, yeah, here. It's usually more like this here. And you can see it's fairly big. It's 32 by 79, so it's big. But it can go horizontally as well, like you can see here. And it doesn't have to be in the sun at all. It can be, because it's actually the most efficient if it's as close to the tank as possible, regardless of sun, because the refrigerant line takes up, it loses a lot if it's too long a line length. So it's better to have short line on a north facing wall than long line with a south facing wall or roof. So typically it's just near the tank, wherever aesthetically works, and as close to the tank as possible.
Can I ask one other question? Retrofitting, I mean, I would think retrofitting could pose a lot of difficulties as opposed to new construction.
Not so much. I mean, the line set is usually the biggest challenge because there's usually a tank there and the new tank just goes wherever the old tank was. The old tank is removed, the new tank goes in the same position. This heat pump unit can be anywhere near the tank, so it can be mounted, there's usually a place to put that. But then running the refrigerant line, you can see here, you usually penetrate right at the base of the first floor and then go between the joists into the basement and run over to the tank. So it's not usually a huge challenge if the tank is near the panel. It can also run outside. You can see they do that with mini splits here. This pipe all here is for the mini splits. So this is actually the space heating system. But for the split heat pump water heater, the pipe is right there. You can see it just going right into the home right there, just below the panel. The mini split, but you can also run like this and cover it if you have to go around a corner or something and cover it in this PVC pipe cover.
Wonderful.
Yeah.
Oh,
The other challenge is with electric, like if you had a gas water heater and you didn't have the electric capacity to add an electric water heater, that's another thing to look at when people change over to electric.
Oh, good. Well, lots to consider. And
Yeah.
I'm sure that, if somebody is needing it, especially as an architect, and you can help, get everything sort of sized and located and guide in in basically the best alternative for the homeowner.
Oh yeah, happy to help. Just contact me, or we do site visits too to talk to the homeowner on site to see what is the best option for them.
Well, thank you very much. I think
Okay.
this was a lot
I
to think
think-
about, and thank you.
Oh, and there is one more question from the attendees from Duran.
Yeah,
Doran.
hi there, John. This was great. This is Doran Hole. I'm also on the committee.
Oh, great.
The question I had for you on the split with the outside condenser,
Yeah.
these cost assumptions. How many feet of line are you assuming there? Just to kind of create a visual of the distance between the outside unit and the tank.
Yeah, the line set has to be with this size, the normal size compressor. The tanks come in three different sizes, 65, 80, 120. The compressor is the same for all of them, and it can handle up to 45 feet of line length.
Okay, and does
And the
that
price
the
is the
difference
same,
between say 15 feet of line length and 40 feet of line length, like what are we talking about in terms of loss of efficiency?
Oh, that's a good question.
Is it material? I guess is really the question.
It's not material. I mean, I would say, the UEF or the COP might go down, by, I don't know, 10% maybe.
Okay.
But
That's helpful.
but what it is more than you'd rather shorten the line length than I think I said earlier than try to get the panel in optimum sun conditions, because
Sure.
that line length will make up for anything you gain.
Well, selfishly, I ask because my house, my boiler room is too small to do the regular one, and
Yeah,
then it's also in the absolute center of the house and not in a
right.
basement, so it
Yeah,
takes a lot of
anything
lines.
under 45 feet
Yeah.
works well.
Okay, that's probably the mini splits work great. But
Oh yeah, good.
the other question, just because folks might want to understand, one comment that you made about the speed with which the water heats up.
Right.
How does that compare to a traditional gas water heater
Oh,
in terms
It
of
it doesn't even
heat up
compare.
time?
Yeah, it doesn't even compare. I mean, you'll have people with a gas water here, a family of four
Mhm.
usually do an 80-gallon tank.
Right.
Gas water heater, you could see a 30 or 40-gallon tank because it heats up so fast, half the size, because you don't worry about people running out. We do 80 gallons for family of four because we want the heat pump to do all the work. So, they might use 40 gallons and go away. And then for hours, the heat pump can run and get the tank back up to speed again. I would say it's, 4 times longer.
But by design, by using a larger tank, you kind of
Right.
avoid
Right,
it becoming an issue for you.
right, right. So
I
we
see.
always try to plan larger tanks. And that's another good thing about the split system is the 120-gallon tank, which you can't even, there might be some available in the unitary, but they're hugely tall, won't fit anywhere. The 120-gallon tank here is the same height as the 80-gallon and the 65. They're all 60 inches tall, just a little bit change in diameter. You can, for families of 5 to 8, you'd go with a 120-gallon tank.
And last question, I promise. The outdoor evaporator panel, I noticed on the pictures, tends to be mounted on the side of the house. Is that
Right.
always the case, or do you
Yeah.
have freestanding like the mini split compressors?
Yeah, and a lot of times we'll mount them, you can see here, near the mini split compressor. They
Mhm.
can be right behind actually, and that's kind of nice because there's airflow from the mini split compressor, which
Mhm.
panels love airflow. So that's actually a nice combination to have that right behind there.
Got it.
Yeah.
Great, thank you.
Sure. Thank you.
All right. Well, once again, lots of stuff to
Sorry it went so
think
long,
about.
Debbie.
Huh?
I'm sorry it went so long. It's supposed to be 30
It's
minutes. I'm
just
sorry.
fine. It's
Okay.
absolutely fine. I think it was full of incredibly useful
Okay.
information.
All right.
And
Thanks.
I thank you and we look forward. Um I'll send you the link when we're done. So some of this will be edited.
Yeah. No
All
problem.
right.
All
All
right. Thank
right.
you, Debbie.
Thanks, John. Take care.
Okay. Bye-bye.
Bye.